Hello everyone, welcome back. We got another laptop for repair. So this laptop came from a customer. So continuously we are receiving this type of laptop. So this brand is Dell and it is Dell 3521. So this is a common laptop that we can see everywhere. Most of the people use these types of laptop. So the problem with this laptop, it doesn't turn on. So the customer said, so he made the laptop in the sleep mode. Then after he tried to turn on, it didn't turn on. So basically the problem is with the no power section. So first of all, we can see whether the laptop is reacting if we plug in the adapter and see whether there's an increase or change in the ampere reading, so that we can get a clue where is the problem in the laptop. Okay, so now you can see the display of the power supply in the screen. Now I'm going to connect the adapter now. So let's see whether there's a change. There's no reading in any ampere. Okay, so let me press the power button. No reactions. Okay, now let me open the laptop and see the problem. So we had to start from the main power rail, from the 19 volt, then back to standby IC and to other sections in the motherboard. Okay. Okay, so now the board is out. So just we can look physically if there's any damage on the motherboard, like any corrosion or any burn marks. It looks clear. There's no burn marks anywhere. Any water damages? No, there's no any water damage. Okay, it's look pretty nice. There's no problem as I visually inspect the motherboard. Okay, now let me plug in the adapter and let us check whether we are getting the main power rail or the 19 volt on the DC jack and see if there's any problem. Okay, now I have connected. Now let me plug in the adapter. The power supply of the display is visible to you now. So the board is currently not drawing any ampere from the power supply. So now let me grab my multimeter. Okay, let's have a basic check whether we are getting the 19 volt on the adapter side. Okay, here is the DC jack connector. Yes, we are getting 19.46 on the DC jack. No problem. Let us check on the CSR, the current sense resistor. No, we are not getting any voltage. Wait a minute. If you look here, this is the current sense resistor and we are getting 19 volt on this side. However, we are not getting any voltage on this side. No, we are getting, okay. Yeah, it's just a short connection problem with my test probe. Okay, so we are getting 90 volt on both sides. So we are having the main power rail in the motherboard, which is 19 volt. Still, you can see there is no ampere reading on the power supply. Now we have to check whether we are getting the LDO voltages. So we can check LDO voltage at the battery connector here. No, there's no LDO voltages. No voltages. So the problem is with the standby section. So there is no LDO voltages. Now let's move on to the standby IC and check its requirement for it to generate those LDO voltages. Okay, so this is the standby IC. So at this point here, yes, it's 19 volt, and at this point no voltage. So we are having 19 volt into the standby IC. So in order for the standby IC to release LDO voltage and also the coil voltage, it should receive the enable signals from the SIO. So we need to check which pins are receiving those enable signals from SIO, and we have to check, and the voltage should be 3.3 volt in order for the standby IC to release the LDO voltage and also the coil voltages. Okay, so now we are looking at the standby IC of this motherboard. So this is RT8205L ZQW. So according to the requirements of this standby IC, so first of all we need to get enable signal at pin number 13 in order for it to release those LDO voltages at this point. So here we can see these two LDO voltages. VREG3 is 3 volt LDO and VREG5 is 5 volt LDO. Okay, so in order to release those two signals, we need to get 3.3 volt at this pin number 13. So otherwise we will not get these two voltages. And also you can see on the pin number 6 and pin number 1, these are the enable and tripper switch to turn on the standby voltages, which is 3 volt and 5 volt with high current. So if we get low impedance at these two pins here, the pin number 6 and pin number 1, there won't be any standby coil voltages, which is the standby ampere, full ampere voltage. So we will be getting 0 volt. However, if we are getting 3.3 volt on pin number 6 and pin number 1, we will be getting both two voltages. So now we have to check first at pin number 13 whether we are getting the voltages. Okay, so if you look here, you can see these components are not installed in the motherboard, which means there is no circuit, this type of circuit in the motherboard. So this pin is just left open. So we should get the voltages once the main voltage comes into the standby IC, which is the 19 volt. So I think there may be problem with the standby IC because LDO voltages should be generated once it receives the main voltages, which is the 19 volt into the standby IC. So where is that voltage? We can, yeah, it's on the pin number 16. So pin number 16, it receives the main voltage, which is the V++ voltage from the current sense resistor. So once we receive this voltage, we should get these LDO voltages. So either there's a problem in the enable line, anyhow I can make sure there is no circuit in this side, so this pin is left open, so it should generate those 3.3 volt and 5 volt. And there's another problem. We can see if the capacitors that is attached to the LDO section, so we have one capacity at the 5 volt line and also one capacity at the 3 volt line. If these two capacitors get shorted directly to ground, so the standby IC will not release those two voltages. If any one of the capacitor is not intact, so it will not release other voltages. So we need to check these two capacitors also. And finally, I can remove the standby IC and replace it again. So just to make sure if there is any dry soldering, so it will cure the problem. So first of all, we need to check these things, and finally we can replace a brand new standby IC. So let's check with the motherboard now. So 13 on this side. Yes, we are getting 2.8 volts. So there is no problem in that line. So we should get the LDO voltages now. Okay, now let me disconnect the adapter and try to check the impedance or the resistance at the LDO capacitors. 257 ohms. Okay, let me check pin number 17 for the LDO 5 volt. So this is, I think, the LDO 5 volt on this side here. Yes, it's 300 ohms. So there's no problem on the capacitors. Okay, so I'll just remove this standby IC and replace it again, just to see whether the standby is back to life. Okay, now it looks very clean and it is well placed in its pads. So now let me try to connect the adapter and see whether there is any change. Let me check whether we are getting the LDO voltages. No, we are not getting any voltage. Okay, let me check the LDO capacitors with the diode value, just to check whether their values are accurate. So now I have not plugged in the adapter, so without adapter we will check the diode value of the capacitors. So it's 465. Okay, the other one is 543. So which says, so there is no problem in that line. And also if we change the probe, we are reading high impedance, which means there is no problem on the output side. So now I'm going to replace this standby IC and see whether we are getting the voltages. Okay, now I have replaced the standby IC. So I think this time it should release the LDO voltages. So watch of the display of the power supply. So we should have a change in the ampere. So there should be at least 1 milliampere intake for the motherboard to produce the output. Yes, we are getting 3 milliamps. So which means now we should have the LDO voltages produced. Okay, let me check on this capacitor here. Yes, we are getting 5 volt. On this side we are getting 3.3 volt. Yes, we have solved the problem. Okay, let me check on the battery connector here. We were not getting any voltages earlier. Yes, we are getting 3.3 volt, 3.3 volt. Okay. Now let me trigger the board and see whether we are getting the board turned on. So I can use the multimeter to trigger. Positive probe on the ground and on negative probe on one end. Yes, the board turned on, but the ampere stuck with 200, so 20 milliamps. So there's some problem with the board now. Okay, let me check all the coils to see whether there is no problem in the coils reading. So usually we check from the current sense resistor to each coils, then back from the inductors to ground. So we'll check one by one. This is okay. This is also okay. This is also okay. This one small one here. Yes, this is also okay. 500 okay. 500 okay. 500 okay. Yes, they are okay. Now let me check with the ground. Each coils 500 okay. 16 okay. 0.006 okay. 2 ohms. It's reading 2 ohms. Most probably this is CPU power supply. This is little bit lower, but anyway CPU is much lower, but not like this, I think. Okay, let's hold it for a second. This is GFX core, 1.1 volt. Okay, what about this one? 177 okay. 454 okay. 447 60 0.116. This is bit lower, I think. It's reading 7 ohms at this point here. This is probably the PCH power, VCCP 1.05 volt. Let me connect it again. Yes, and now let me check whether we are getting the coil voltages. Yes, 5 volt is present. 3 volt is also present. Now I need to trigger the board and see whether we are getting high ampere. The ampere is still at 20 milliamps. No problem. So actually this board is trying to turn on, but something is making for it to not to release the S4 and S3 signals from the PCH. Because if you see, the ampere is taking around 22 milliamps. So when I press the power button, so EC on this motherboard, which is this one here, so this chip here receives the power button signals and send the power button output to this PCH here. Then PCH will release the S4 and S3 signals. So the S4 signal will come to this point here, which is the RAM power supply. This power supply will generate 1.5 volt to this chip here, and also the S3 signal will turn on the bus power supply direct media interface from PCH to CPU, and also other run power switches, and also finally the CPU voltage. Now we are having a problem. Either the EC chip is not releasing or it's not turning on the S4 and S3 signals after receiving from the PCH, or PCH is not sending S4 and S3 signal. So there is something problem with that. So we can start from the EC chip here and go back to the PCH and find which is causing this problem. First of all, I will check with the oscilloscope for the standby section to see if there is any strange signals or strange rise in the 5 volt and 3 volt. Okay, now I will set to trigger mode. Single edge, okay. Let me connect again. Yes. So we have a nice rising edge. So there's no problem with the standby section. So this is 3 volt, I guess. Yes, this is 3 volt. So this is fine. So you have nice rising slope. Now let's check again from the standby section of 5 volt. Yes, let me connect the adapter again. Yes, we have a nice rising edge there also. No problem in that. Okay. Right. So there's no problem with the 5 volt and 3 volt standby. So let's go back to the EC chip here and check its requirements. Okay, now let me start from the EC chip and check its requirement. So let me plug in the adapter. So if you look here, just I have made a jumper from the power button because the power button on other side, so I can't just press it. So I will just short this little wire to the ground in order to trigger the board. Okay, now we can check at pin number 37 of EC chip here, which is the EC reset signal. So we should get 3.3 volt at that pin in order for the EC chip to function. Okay, now pin number 37. So pin number 37 is 33 on this side, 34, 35, 36, 37. 33, 34, 35, 36, 37. Yes, so we are getting 3.3 volt on the EC reset. So that is working fine, no problem. So now the board has triggered because it is reading 22 milliamps. And we have to check the other signal is the RSM reset signal. So the RSM reset signal is on pin number 100. So this signal is responsible to ensure that the EC chip is working fine, and also the BIOS inside this EC chip, which is inside this EC chip, is working fine. So if the BIOS is corrupted, RSM reset will not be released. So we have to reprogram this chip. So I will just check that pin also on pin number 100. 97, 98, 99, 100. I'll just trigger the board. Okay, the board is triggered and we are getting 3.3 volt, you can see. So the RSM reset is also okay. So now let me see whether we are receiving S4 and S3 signals from the PCH back to the EC chip. So we should have 3.3 volt on the specific pin which receives the EC SLPS3 and SLPS4. So before pressing the power button, we should get low impedance at those pins. So let me check pin number 6. So on pin number 6 we have one of the signals, which is S3 signals. It's on pin number 6. So 1, 2, 3, 4, 5, 6 is at this point. Okay, now we are reading 482 ohms before pressing the power button. Okay, but after pressing the power button, we should have a high impedance. Yeah, we are having 44 kilo ohms. So let me see whether we are receiving the voltage, but there is no voltage. So we can conclude that the PCH is trying to release the S4 and S3 signals, but something is hindering the PCH in order to release those voltages. Those signals, you can see the low impedance is rise to high impedance when I trigger the power button. Let me check the output signal from the EC chip, which is the system on and susp has signals respective to the S3 and S4 signals that receives back into this chip here. So on pin number 95 we have this signal, which is the S4 signal respective to S4 signal 95. Yes, it's 66 ohms. Now I am going to trigger the board and see whether there is any change. Okay, now I have triggered. Let me plug it, unplug it. Okay, again I will trigger the board. Okay, the board has turned on. Still it is at 65 ohms. Although I have triggered the board and our ampere is taking around 20 milliamps. So there is no change. So EC chip is not releasing those S3 and S4 signal because it is not receiving the signals. Although we are having high impedance in those two pins here on pin number 6 and pin number 14, but there is no voltage, so that's why the EC chip is not releasing the system on signal and also the susp has signals. Okay, now let me see the power management sections of the PCH. So basically we know always voltage 3.3 volt is supplied to the to the PCH here. So we need to check that voltages whether they are present in that. Okay. This is the QZ3 chip, and on this side on the drain point it receives the 3 volt always voltage, and also it goes to this side here back to 3 volt PCH. So we need to check the voltages now. So I am connecting the adapter. Okay, and if I check at this point we have 3.3 volt, and on that side, oh, we don't have voltages on that side. Okay, so this is the problem. Okay, let me check the ohms value on the output side of this chip just to confirm whether there's no short. That we have 16 20 kilo ohms and it is increasing, so it's we are having a high impedance on output side, so there's no problem. So we know this is an n-channel MOSFET, right? So for an n-channel MOSFET to switch to output side, so we need to get a higher voltage on gate with respect to source. So on the gate we don't have any voltages, and also on the gate on the source also we don't have any voltages. Okay, now I think these are the circuits, this chip and this chip here, the small one. These are transistors and MOSFETs which switch on the signals to this chip here in order to release this 3 volt as a 3 volt PCH. Okay, now let me check these two chips whether they are working correctly. Okay, so when you look at the n-channel MOSFET, so in order for this voltage to switch this side, we need to have a higher voltage on the gate with respect to source. So if we are getting 5 volt on this side, or else we can say it is 3 volt on this side, either we should get above 5 volt on this side, then only we will be getting 3 volt on this side, on the output side. So we can see here B bias voltage. So B bias voltage is actually the adapter voltage, which is 19 volt mostly. So this 19 volt goes into this resistor and go back to this gate here. So this is the MOSFET that controls this voltage from going to this side or being protected from going from this side. So this is the signal that comes to this chip here, the N-channel MOSFET, in order to switch off and on this signal going back to the gate of this N-channel MOSFET. Actually, we should receive ground at this point or else 0 volt, because if we receive voltage at this point, it will transfer the ground to this point here. So this high voltage will not pass after this resistor, and there won't be no trigger back to the gate. So in order to solve this problem, so we need to prevent the voltage from going into this N-channel MOSFET. Then there won't be switch of this ground back to this place, and the B bias voltage will go straight into the gate of this MOSFET, and the N-channel MOSFET will switch 3 volt back to this side as 3 volt PCH. So first of all, we can check this N-channel MOSFET here. Sometimes there are options if this MOSFET is not working or this MOSFET became faulty or there is no voltage on this side. We have another option here, which is we can remove every parts in this here in this section, and we can just jumper these two wires, and we will be having the 3 volt PCH here. So just for the sake, we can test whether what is the problem in these sections and try to solve it as much as possible. Okay, the adapter is connected. So this is the Q set for MOSFET, N-channel MOSFET, that switches 19 volt back to this gate pin here of this MOSFET. So this is the drain point, and this is the source point, and this is the gate point. So now we should receive 0 volt on this gate so that 19 volt can pass to this chip here. So let me check at this point. So you can see we are receiving 5 volt. So if you are receiving 5 volt at this section, so it will pass the ground from this point to here, which will protect from 19 volt going into this gate here. So we have to find why it is receiving 5 volt signals. So this 5 volt voltage directly comes from the EC chip, I guess. So anyhow, I have to find where it is coming from. So we can search that from the schematic. Okay, if you look here, so if we connect this signal here, it comes from this point. So we know we should not get 3.3 volt at this point. So we should get ground or 0 volt. Or 0 volt. So in order to get 0 volt at this point, we should bring this ground at this place here. Then only we will be getting 0 volt at this point. Otherwise, this 5 volt will go to this line and come to this MOSFET here. So in order to prevent this voltage from going from this point to this point, we should get 3 volt at this point here. So which should be 3.3 volt. So let's check QSAT10, where we need to get this 3 volt at this gate here. But if you are not getting any voltage at this point, we can just jumper this wire here, or we can put some resistor at this place and make it 3 volt to go to this gate. So it will automatically switch the ground to this place, and we can get the 19 volt back to this point here, and it will switch 3 volt back as PCH. Okay, so here we have the QSAT10 at this place here. So we need to check the gate of this N-channel MOSFET, and we should get 3.3 volt. So this is the gate, and we are not getting 3.3 volt. So this is the problem for us to have 5 volt at this point. So if we have gate at this point as 3.3 volt, the ground at this point will travel to this point here, and it will block the 5 volt, and we will be getting 19 volt for the gate of that big N-channel MOSFET. Okay, now let us check the resistor that is responsible for giving that voltage. Okay, when you look at this signal, PCH power enable, it comes directly from the EC chip. So we need to check pin number 26 whether we are getting any voltages. So if you are not getting any voltages and if there's any low ohms at this site, so we need to remove this MOSFET, this resistor, because there's a problem inside this EC chip. So we can remove this resistor and we need to do another work, which is so we need to place a resistor at this place here in order for this voltage 3.3 volt to pass through this resistor and go back to this gate. So we will get this MOSFET to turn on and will transfer the ground to this place. So we can remove either this 100 kilo ohm resistor and place it at this point. So we will be getting pure 3.3 volt at this gate here, because we are not getting 3.3 volt, which is the PCH power enable, from the EC chip because it has some problems internally. So we can just isolate this line from the EC chip by removing this resistor here, which is this one. So we can remove this resistor here so that we can isolate this pin from this side and we can give voltage back to the gate of this MOSFET here through placing a resistor at this place. So let's do it. Okay, so this is the RE26 resistor which is connected to this pin here, which is responsible for switching PCH power enable. So now we are going to remove this resistor and provide external voltage at this point from the other side so that we can get 3.3 volt at this point. So now I'm going to remove this one. Okay, now the resistor is removed. Let me check again on this point whether we are getting high impedance at the output side of this resistor. Yes, there's no beep, there's no sound you can hear, there's no sound at this point. Yes, we are getting the sound, which means there's a problem on the EC chip here. That's why it is not switching. Okay, now let me connect the adapter here. So the adapter is connected and I'll try to trigger the board. Yes, still it is at 58 on the other side, so there is no connection. So now we don't have voltage at this point, so we need to bring 3.3 volt at this line here. Okay, so this is the resistor, so we need to remove this resistor and place it on this side, so we will be getting 3.3 volt for this gate here. Okay, it looks fine. Now let me cool down the board. Meanwhile, I can clean the area. So we need to get 3.3 volt at this pin. Yes, we do have 3.3 volt, and we should have ground at this point. So 0. So by now we can check at this point here also on the PCH 3.3 volt. So we were getting 3.3 volt on this side, but on the other side we were getting 0 volt. Now we are getting 3.3 volt. So we have solved the problem, I think. Okay, again I will trigger the board, turned on. I'll just connect the mouse here. If it's working, I'll get the mouse LED. Okay, let me change the RAM that I have with me. Okay, now let me check with the oscilloscope whether the RAM has passed and the RAM is detected with the motherboard. Pin number 202 is the data. So now I'm going to trigger the board. Okay, the board has turned on and you can see there's a reading on the oscilloscope, which is the RAM has detected by the motherboard. So let me turn off and on again. Okay. Okay, it's again turned on. Yes, the RAM has passed. You can see the waveform. Okay, so now let me check the LPC communication of the EC chip. So we can see at pin number 10 of this chip here, pin number 10 at this point here. Okay, let me trigger it again. Yes, it's turned on. Yes, we do have some reading. You see? Yes, the LPC communication is there. Actually, if you are getting LPC communication, the display should be generated, but we are not getting any caps lock or number lock on the keyboard. Anyhow, for the sake, I'm going to put this in the laptop and check with the display whether we are getting the display output. Okay, and let me power on and see whether we are getting display, because we are reading LPC communication. Yes, we got display.